Alrighty. Hello and welcome everyone to this live stream on our MATLAB YouTube channel. My name is Connell D'Souza. I work on the student programs team here at the MathWorks, and I'm joined by my colleague Sam.
Yep. If you were here last week, you probably recognized me. We did a stream on Simulink Basics, and I promised I would be back to talk about code generation.
Yeah. So, we've got Sam, who's a veteran live stream expert at this point. All right. So Sam, what are we going to talk about today? We're going to talk about code gen. Right? Code gen is a pretty big term. What have you got on the agenda for today?
So if you're not familiar, this is a workflow that's really common, especially when you're working with embedded hardware. And you can do it in both MATLAB and Simulink. We've got a couple examples from both that we're going to talk about. But essentially, when you're doing code generation, you've started out in MATLAB or Simulink. You've developed an algorithm for something. Maybe you've prototyped it against a simulation model, which we kind of talked about in the Simulink Basics live stream. And now we want to actually take that, and instead of running a simulation with it, we want to move towards using it in the real world,
right?
Or as real world as a live stream studio gets.
Right.
So what we're going to do in order to do that, because we don't want to run like MATLAB or Simulink itself on our hardware. Most of the time, we got a gaggle of different stuff on the desk here. An Arduino. I've got a Raspberry Pi hooked up, and then Connell, this is a NVIDIA Jetson.
It's an NVIDIA Jetson TX1.
TX1. Okay, so
older generation, but old is gold, right? Let's hope it doesn't break.
Yeah, but so what we're going to do is we're actually going to take our MATLAB code or our Simulink model, and we're going to generate C code that we're then going to deploy onto our embedded device. We've got, mostly because it's nice and flashy, we've got a couple webcams hooked up, one to the Pi, one to the Jetson here, to kind of demonstrate some computer vision stuff, mostly because it's the easiest thing to sort of take from, okay, maybe I'm working with it in simulation. Right. I want to work with a real camera on my hardware now, right?
And I guess part of the philosophy is when we always, at the MathWorks, we love model-based design, right? This all sort of ties back to model-based design, because in model-based design, you as an engineer, you're not really an expert on the low-level embedded code, writing the C++ portion of it. I know I'm a mechanical engineer, so I've never really been a C++ guy. But with what CodeGen and MATLAB and Simulink gives me the power of is I'm able to write code in a language that I'm familiar with, like MATLAB or Simulink, and then essentially pretty much click a few buttons, write a couple lines of code, and we can generate C++ code that's optimized for embedded hardware. So why don't we get started? We're going to start with a MATLAB example. We did a live stream on CodeGen about a year ago, I believe, Sam, and we showed you how to sort of generate code from a MATLAB function, but we got a lot of questions at the time about this concept called MEX. Okay, so MEX is MATLAB executable. So I guess we're going to show you a little bit about not just generating code, but also how you can use MEX files to speed up your MATLAB code. So let's jump right in. So what we're going to do today is I'm a big fan. So whenever I'm trying out something new in MATLAB, there are documentation examples for literally everything, right? So what we're going to do is we're going to pull up a doc example. This is available in the MATLAB. Excuse me. This is available in the MATLAB Coder product, and if you can see my screen, it's the title of the example is C code generation from a Kalman filtering algorithm. Now, the idea is, what we care about here is we don't really care about the algorithm as much as converting that MATLAB algorithm into C++ code, right? So, let's open up this live script and see what's going on in here. So I've got it already opened up in MATLAB, and as you can see, this is a MATLAB live script. The cool part about MATLAB live scripts is you can have both rich text, images, GIFs, whatever. Yep. And code within the same file, right? So let's take a look at what this function does or what this piece of code does. So I'm going to go ahead and run this section real quick. And essentially, what you see here is I've got this kalmanfilter.m file. if you guys open up the doc example and look through it, essentially it's a pretty simple Kalman filter algorithm. There's nothing too fancy going on here. You're setting up some, if you're familiar with Kalman filtering, essentially what this example is doing is think of it as a bouncing ball. So a ball's bouncing around, and then we're going to use a Kalman filter to estimate the trajectory of that ball, right? So what you see up here is the code. We're not too concerned with it because our goal is we're not worried about the algorithm as such as more generating code from it, right? So let's go ahead and load in some data and see what this algorithm actually does. So while this thing runs real quick, let's just give it a second.
There we go.
There we go. So essentially, essentially what you're seeing here is you have the blue markers on that plot are the actual trajectory of the ball bouncing, and you can kind of see it's got those little humps in it. And then the green markers on the screen, that's the algorithm actually trying to predict what position the ball is in, right? So it's as you can see, the algorithm's kind of at the start it's a little funky. It doesn't really catch it all the way, but it sort of gets better over time, which is kind of true with Kalman filters. It takes a little time to converge, if you will. All right, so that's this is what our code's doing. Let's go ahead and take a look at this object track function that we've got in there. So I'm going to go and hit run section again. Oops, that was the wrong section. I'm sorry.
Well, now you gotta wait.
Yeah, MATLAB kind of locked me on. Oh, I see. We've got a few people in the chat saying hello. So, hello, Abhishek. All right, but if we go and inspect this little piece of code, code called object track, you can see essentially we've got 300 points, okay, and we're looping through these points. So we've got a bunch of z positions. So you see z equals position and then an ID. So it's essentially going to go through all of those points and then use the Kalman filter to predict what is the position of the ball, right? So we've taken a look at the plot. We've seen what this does. In fact, we can actually, this plot's kind of cool because you can animate it and see what, so you can see it actually bouncing through.
Yeah, and that's because when you ran this section of the live script, it was updating this plot throughout the loop.
Yes. So we plotted all the positions. Now we're able to play it back, right? All right. So let's jump right into creating the C code, right? If you saw our last live stream a year ago, we went through the MATLAB Coder app. There is an app workflow. Again, at the MathWorks, we love apps. We have an app for everything. The app is one way to go about it. It makes it a little easier because you can like point and click, and you don't have to like really write a whole lot of code. But for the purpose of this demo, we're just gonna all of that app essentially translates to this one codegen command, right? So codegen command, when you talk about configurations, you can generate code to do a number of things. You can generate it to do to create a library. So static or dynamic libraries that you can integrate it with other code bases that you've got. So say you're working on a team with a few people, and there's a particular algorithm in MATLAB that you really like, but you also got other code that's in a different language, in C or C++. You can just take the MATLAB portion of it, generate a nice little library or a nice little function or an executable, and integrate it somewhere else. So what we're going to do is we're going to call this codegen command. Okay, ask it to generate a library for that function that we've for the Kalman filter function that's actually tracking that trajectory. The next tag, which is report, that'll just generate a report, so we can see what the code's what it looks like, various other things like that. The next tag of C, that means we want to generate C code, and then after that you have to give it the name of the function that you're generating code for. So Kalman filter M, which is a script. If you open the documentation from our doc examples, you will find all these files in there.
So what is that last one with the arguments?
That's a good question. So args is essentially any arguments to the function that is being that you're generating code for, right? So if we look at our Kalman filter function, I'm just going to scroll up real quick. Notice that you have that this is the function called y equals Kalman filter of z. So essentially, it's taking that position, the z position of the bouncing ball. It's taking that as an input argument, right? So you have to give it the input arguments when you're generating code as well.
So that it knows what kind of argument to expect.
Right. It knows what data type it is, what size it is, various kinds of things like that, right? And if you see what we're doing above is we're just saying z equals position. So we're just taking the first the first element of that position vector because we're able to tell it that okay, this is what to expect. To expect a 2x1 a 2x1 array coming in, right? So let's go ahead and hit run on this section. We can generate code for this. So this usually takes a few seconds. And as you can see, it's telling us that the code generation was successful. If you want to see where the generated files are, you can go back to your current folder, and you'll find a CodeGen directory in there. So this is where all the generated code goes and lives. So if you remember, we asked the CodeGen function to create a library. So you see a lib folder in there, and this is where all of your files are, right? So you can see a bunch of .c, bunch of .h, and it's pretty cool because like you can just as well take this into Visual Studio or any other IDE that you have and edit these files, right? Do you want to edit it? Probably not, because the code that we generate is kind of optimized, right? So you don't want to be messing around with the generated code. If you ever want to make a change, our recommendation is you make it up in the MATLAB higher interpreted language, right?
Because the risk you run into is if you, especially if you're making changes to the algorithm itself, if it's oftentimes what you'll do is you'll generate the code here, and it'll have a function that you can call.
Right.
So you might write another C file where you're calling that. But the risk if you go and you modify what the actual algorithm is now you've got two different versions of your code that are going to have two different results.
Right.
Whereas if we keep that C code that was generated as is, we know it's going to match the MATLAB file.
Right. All right. Cool. So let's go ahead and take a look at this report and see what's going on here. So this report's really nice. So what we see over here is we've got KalmanFilter.m. This is the .m or the MATLAB file that we've generated code from. This is similar to what we saw in the live script earlier. But I believe this was maybe 2 or 3 releases ago that they released this trace code feature, which is kind of cool. So let's see what it does, right? So you click on trace code. What this is going to do is it's going to tell you what line of MATLAB code corresponds to that particular section of C++ code. I think this is a real testament to the power of MATLAB because you can see the .m file that we wrote had about like 30 lines of code, 32 lines of code. That generates a KalmanFilter.c file, which you can see down here, but that has a lot more lines of code. So your choice is either writing those 30 lines of code in MATLAB or writing the hundreds of lines of code that you need to do it in C to get equivalent functionality, right? So so line 22. This is one of the calculations that we're making. We're essentially predicting a state, and it's just a part of the Kalman filter algorithm. Again, we're not really interested in it, but if you click on it, you'll see that corresponds to a particular section of the C code, right? So this is a good way for you to inspect what your code looks like once it's been generated. You also have the option here to package your code, so you can choose a hierarchical structure, and then or a flat structure. Everything comes in a single file. There are different options, but essentially what will happen is it'll package all the files that you need to run this code outside of MATLAB in a nice little zip file that you can hand over to your other teammates, right?
Awesome.
Yeah. So let's go back to the script real quick. So we've only generated a library so far. We're not able to. You can take this library somewhere else. But what we're going to look at today is we're going to look at how to use mechs to speed up our code, right? Because sometimes you've written an algorithm in MATLAB and you find that the performance is you could like it to be faster. You know that Because MATLAB is a high-level interpreted language, you want something that's compiled, right? You want something that's not calling the interpreter every time.
Yep.
So that's what we're going to do, right? So we've taken a look at what the code looks like. Let's actually in order for us to assess how much quicker mexing helps, let's do a baseline start to see what this function, if called multiple times, how much time it takes to run, right? So I'm going to go ahead and run this section here. Oops. Oh.
What did you do?
I don't know. I broke something. It's not. You know why? We're not in the right folder. That's why.
Yeah, because you. Of course.
But anyway, all right. So let's go and take a look at what this Kalman loop function is doing. So essentially, it's just it's for a given size of z, which is our position. It's just running the Kalman filter function through the loop, right? So again, nothing crazy. We've seen this. We know what this does. Let's run this section to get the baseline and see what's happening in here. So.
And this is using the MATLAB code.
This is using the interpreted MATLAB code. So essentially, what we're doing is we're giving it a bunch of random positions, and then using a tick-tock to measure how long it takes. So we say that it's 0.68 seconds. Okay, so it's fairly quick. But again, that's the power of computers. We can get really quick with it, right? Let's go into creating the MEX file, right? So MEX is essentially, once we've generated the code, MEX will just compile it and create a MATLAB executable about it, right? So notice again, we've got that same code gen function that we called earlier. We've got the arguments. In this case, we're giving it a position argument, which is the same as what we had given z in last time. And then we're giving it the name of the file that we want to generate code from. So Kalman underscore loop. Right? So let's go ahead and run this and generate the MEX.
So I see there's a question from the chat here, Connell. Nabab asked if you could get this code. This is an example from the toolbox, right?
Yes, we can have our video guys pop it in the chat for you, pop a link to that in the chat for you, so you can code along. But all right, so we see that it's telling us that code generation is successful. It's also telling us where this particular file is located. So if we go back to our current folder, what we should see is now a Kalman underscore loop. So Kalman underscore loop underscore MEX. So that's the MEX file. Okay, it's a MATLAB executable. It's not interpreted code. It's been compiled, right? So this is the actual MEX file. You can just call it like a MATLAB function, and it works just as well. If you go into the code gen directory and you see the MEX folder, this is where all the files that were used to compile the MEX are located. So you can see that MEX file in here as well as a bunch of .c and .h files. All right. So anyway, let's go and see how much we were able to speed up the code, right? So again, we're doing the same thing. We're going to use a tick and talk to calculate how long it takes to run this MEXed version of the file, right? So I'm going to go ahead and hit run section real quick. And as you can see, the time that we're getting now is 0.04 seconds, so significantly faster, right? I've actually got a little line of code here that can tell you exactly how fast it is, but it's 17 times. Yeah, so that's pretty good. It's pretty significant, right? Like if so. So this is more a step that you take once you've developed your code and you know that, okay, I don't anticipate changing my function. I've got this function down. It's good. I just need to run it multiple times, right? So obviously, the more times you run it, the better the speed up is, right? So once you sort of figure out what you want to do with your code, you could MEX it and use it in your code base moving forward, and you can get a significant speed up on this.
And 0.6 versus 0.04, it doesn't seem like a lot, but we're also working with a pretty simple set of code here. If this was a more complex operation, or even it's like a whole simulation or something that you're trying to run with different parameters, if you can take it down from 17 minutes to 1 minute with a 17 times speed up, that's a pretty significant difference. You know, it's a difference between a coffee break and you know, maybe just checking Teams really quick for a chat.
Right. So there's a lot to be spoken about MEX. I feel like I've spoken to a lot of customers that did not know what MEX was, and it significantly helped them because they were able to get their code to run a lot quicker. So yeah, I mean, if there's now's a good time to ask us any questions about MEX if you have any. We're going to try and take as many as we can. But yeah, this is one way for you to speed up your MATLAB code, right? But it's also it comes under the realm of code generation. Essentially, the next step to this would be to generate a generic executable, right? So this is still a MATLAB executable. You still need MATLAB open to run this. You can just as well with code generation create a generic Windows or Linux executable that you can run outside of the MATLAB environment. You don't need MATLAB open. So if you're working on things like robots with embedded systems or what various other projects, you can create those executables and put it onto whatever system you're working on.
Yeah. And in addition to generic executables like that, running it, there's all the MEX stuff we've been talking about here. This is still running on our laptop, right?
Right.
We're not really going anywhere with it. The stuff we're going to talk about next is actually getting code like this that we've kind of prototyped in MATLAB onto hardware that we're working with.
Right.
So let me pull this up here. So I've got a couple things set up here. I am hooked up to a Raspberry Pi, and the code that I've got here, let me actually zoom in on that to make it easier, is again, not super complicated because I want to keep it simple enough that I'm not going to be sitting here for 10 minutes or something while it code gens or deploys to it. I also, full transparency, I was running on a different Raspberry Pi yesterday, and I actually broke it, and I'm not exactly sure how. I can't get it to boot, so I had to switch to an older Pi that I have. So it's not as powerful. So it's a good thing I kept this pretty simple.
Hey, I mean, is it really? Are we really doing hardware demos if something doesn't break the morning off? I mean,
no. Hey, day before,
No, but it's only a hardware demo if it breaks the morning off, right?
That's true. But probably the obvious first question here is going to be, well, how do I actually interact with my hardware here? Because we've got 3 different types of hardware that we might be interested in interacting with: an Arduino, Raspberry Pi, the Jetson. If you're in MATLAB, you can come over here to the add-ons button up here. And I've already got them installed, so for me, I just pop this open, and if I go to, I'm just going to go ahead and search Pi. Bunch of stuff that I've got installed right now. But you can see I've got like this, I've got a Simulink support package for Raspberry Pi hardware. I've got a MATLAB support package for Raspberry Pi hardware. And I have those installed because if I just click on the add-ons button itself, this is going to look at not just things that MathWorks has posted for add-ons. You can also search for like file exchange posts. So it can be really helpful if you're like, has somebody written code to do this before? Or I get a lot of like small utility functions that other people write off of the file exchange that do just small things that I rather than rewrite it 20 times in different places, I can pull it down.
Think about it. There are over 2 million MATLAB users around the world. Whatever you're trying to do has been done before. You're not the first person trying to do it. So file exchange is where I look all the time to find little functions that people have written that are super helpful.
So I'm not doing a great job of searching, but if I wanted to, say I was going to interact with my Arduino over here, if I search Arduino, and hopefully I spelled it right, you can see I've got the MATLAB support package for Arduino hardware and then the Simulink support package for Arduino hardware. There's other hardware that we've got support packages for. There's also hardware that MathWorks may not have a package for, but somebody else may have written one that we've kind of helped them work with. If you go to It's just mathworks.com/hardware. You get to our hardware support page.
Right.
And so if you've got a piece of hardware you're interested in getting connected, or maybe you just want to look at like what's available from different hardware vendors, you can look on this page. This is super helpful, especially we've got a closet full of just like random stuff we've collected over the years. Finding the right hardware support package for it is pretty easy as long as we know what hardware we're working with. I see there is a question in the chat that we can maybe answer really quick.
Yeah. So Kamta asks us, how will you generate C code from a script which calls many functions? It's actually the same process. So first of all, you never generate code from a script. You always generate code from functions. That's the it's like you need an entry point function, right? Because that's what your generated code will be, a function that you can use somewhere else. So you never generate code from a script. It's always from a function. But as long as all the functions that you're calling within that one function, right? It could be nested, could be whatever, as long as they're code gen compatible. If you go into the documentation, there is a list of code gen compatible functions. But as long as all the functions within your script are code gen compatible, it shouldn't make a difference if you're making calls to multiple functions in there. The process is still the same.
Yeah.
Okay.
And somebody else asked, we haven't gotten to Simulink yet, but somebody did ask if you can generate a MEX out of a Simulink file. I don't think you can generate a MEX specifically, but you can, like we're going to show in a bit, you can generate C code from it. And there's a couple different ways to go about it where you can do what's called software in the loop testing, where you will generate C code, and then instead of running the Simulink model and using the Simulink interpreter, you'll actually execute the C code in place of the Simulink file.
Right.
I think if you've got it set up for CodeGen, it's just one of the options in the simulation mode when you drop it down.
Right.
So it, in general, tends to be a performance speed up in the same way that MEX is, but you can't really generate a MEX directly from a Simulink file.
If you're using an older version, if you've been using MATLAB for a while, they used to have this thing called S functions, which you can use, which is essentially taking C code and taking C code written somewhere else and putting it into a Simulink model, and you can essentially follow that process, right?
Yeah.
As well. But yes, the SIL, software in the loop mode, in a Simulink model will just generate code and run a compiled version of your Simulink model, right?
Yeah. Okay, so I've got my Raspberry Pi set up here.
All right.
And let me make sure that I'm still connected to it. All right, I am. So this is just, I'm remoted into my Raspberry Pi. I've got an Ethernet cable hooked up to the back of my computer, so I don't actually have Wi-Fi at the moment. But so I've got my Raspberry Pi hooked up. I have some I/O hooked up that I'll talk about in a second, but the main thing is I've got this USB webcam. It's pretty generic, it's pretty old, it's not a great webcam, but it
does the job.
It does the job. I'm not using my Raspberry Pi for work calls, so it's probably fine. But so what I'm going to do, just to sort of get us started here, working with the hardware itself, is I'm going to run a pretty simple edge detection algorithm. It's really just doing a convolution of a little kernel that we've made with an image that we're capturing from the webcam. So if I run it, instead of running it on the hardware, I'm just going to really quick run this algorithm example on peppers.png, which is one of my favorite little demo images. And you can kind of see it's pretty good. It's not going to be perfect because of the way that we're doing this, that matrix that we're doing the convolution with. Right. But it gets a lot of the detail that I'm looking for, especially like the edge of the peppers and stuff like that. If I wanted to go deeper into edge detection, maybe get rid of like these splotches, I probably don't want those.
Yeah.
I can throw out a lot of this, and there's a lot of different stuff in the computer vision toolbox and other image processing toolboxes.
But again, I mean, the idea here is we're looking at the code gen piece of it, right? We're not concerned with the algorithm as much.
So the next thing I'm going to do, I'm going to take the same thing, and this is sort of the piece by piece kind of build it up workflow that I tend to do, especially with hardware, because stuff tends to go wrong really quick if you just assume things are working, is that now, instead of doing that static image, what I'm going to do is I'm going to, in MATLAB, so I'm still running the code on my laptop, I'm going to run the exact same algorithm, the same convolution, but I'm going to connect to my Raspberry Pi here. So in my script, I'm just creating an object for my Raspberry Pi, creating an object for the webcam that I've hooked up to it, and then I'm doing, in this for loop, where I get this snapshot from the webcam, and then I'm just going to do the same method that I did before.
Right. Just put it into a loop. Yep.
So I'm going to run that, and I should get a little pop-up in a second. All right, so you can see the field of view is not great, but I've just got some cool little stuff that I can put in front of it, kind of get an idea of what's going on. This was just a model I had sitting on my desk. Yeah. If we put, the Arduino in front of it,
that one's kind of sweet.
Nice and detailed, and we can see
we're got a lot of details. Yeah. Right,
yeah. And we're capturing all of these things with that pretty simple convolution. So. It's not perfect for, maybe if in the future I want to use this to actually do something dynamic.
Right.
But in terms of, okay, I've got it running, I've got the interface with the Pi, that's great.
But essentially, I mean, that's like a couple lines of code. The Raspberry Pi is embedded Linux. It's like as someone that is not a programmer, I'm not a big fan of embedded Linux.
Yeah, I've messed around with it before. I have a couple Raspberry Pis at home that I work with, but it's oops. Well, that's because I killed it right in the middle of the code, but it's fine. Errors are fine as long as you know why they happened. But all right, and then there is a couple questions that we're getting about connection issues, recognizing an SD card and connecting in general to hardware. Is there general advice for support where to work? MATLAB Answers is a great place to start, especially if you're having problems with when you install like a Raspberry Pi support package. If you're having problems getting the SD card to be recognized.
Weren't you having problems with the SD card yesterday?
Well, I broke the SD card reader on my other Raspberry Pi, so yes. But what can sometimes happen, especially because I have a micro SD card on here, but I don't have a micro SD card on my laptop, so I have to use a converter. Usually what I do is because I can just download the Raspbian image from MathWorks, I go into like the disk manager and I actually just completely delete the volume of whatever I had on that SD card before. When in doubt, turn it off or delete everything and turn it back on again. But yeah, I think starting with MATLAB Answers is definitely a place to look. That kind of stuff, I've run into it. It's just one of those things that happens when you're working with hardware is sometimes the setup is slightly different. The SD card slot on your computer might be a little bit different.
I think in terms of connection issues, I think something that I've found out that really helps is if you, one of the ways that you can build code onto the Raspberry Pi from MATLAB and Simulink is you actually build it over an Ethernet connection, right?
Yes.
So I used to have a very hard time connecting to both the Jetson and the Raspberry Pi until I went and set a static IP for both the devices. So once you do that, the moment you plug it into your computer, it should, if you set the static IP address right for your Ethernet port, it should be on the same network. So you can just plug it in. And in fact, we were just doing that 10 minutes ago before we started, right?
And specifically, the problem that I know you were running into, Connell, is you can see that the local IP of this Pi is 169.254.179.167. Is if you're on the wrong subnet, so this 179, if your IPv4 IP address is not on that same subnet, that same, if the third number is not the same, I'm mechanical engineering, so forgive me. Then oftentimes you're just not going to be able to connect. So manually setting the IP address of the host computer to match up with it is usually the first thing you want to check if you can't connect to it at all. All right. Really quick, so Raspberry Pi webcam. Before, I was basically getting that image back into MATLAB, so I was still running it on my laptop here. Now what I'm going to do is this model, or this script function I've got, it's almost identical to the one we were just looking at, but there's two things I added. The first one is this cogen directive tag. So it's a comment, so %, and then a hashtag, a £, whichever one you're used to calling it, and then cogen. If you're planning to cogen a function like this, this will basically tell the MATLAB interpreter that it should warn you about things that aren't going to be supported for cogen.
Right.
And then I'm doing the same thing. You know, I'm making my Raspberry Pi object, getting my webcam. But now instead of show, I'm using this display image because I'm actually going to, if I had like an HDMI cable hooked up to my Pi, I would be outputting the image I'm looking at there. In this case, I'm remoted to it using VNC viewer, so I can just pull it up without having to switch cables around. Because I think we have enough hardware going on. We don't need to try and
a bunch of stuff going on up here.
So what I'm going to do here is I'm going to create a target hardware object. This is because I'm doing this purely in MATLAB. I'm not trying to use Simulink or get anything else involved. I'm going to create an object that's just telling MATLAB like what hardware am I looking at, where is it located, that kind of stuff. Oh, luckily it did blurred my password for me. Even though I think that's the default password. And then what I'm going to do is I'm going to deploy this function to my Raspberry Pi, and I'll zoom in on that. And I'm just going to call deploy. I'm going to pass it my board object and then the function that I'm trying to deploy. So I'm going to do that, and then I am going to open VNC viewer. And it'll take a second because it's going to do the code gen in the background. Give it a second.
All right. Looks like we got a question up in the chat. So Shariar asks us if I never get to use the code generation with the Arduino Uno. It always gives me an error, although it works perfectly with the TI Delfino. That's funny. I feel like for CodeGen, the Arduino Uno probably has the best support package. Like you plug it in, it works. I've never had a problem with that support package. But yes, I wonder if you have to set up your, because I know when you set up the Arduino Uno for the first time, you have to go and assign a COM port to it so that MATLAB knows which COM port it's connected on. So I wonder if that's an issue that you're facing but you have to go and like manually select the COM port.
Specifically, I have seen an issue in the past. I was helping somebody with this, where if you have the Arduino Studio, the IDE for it, if you have that open, it's actually holding the COM port, and so MATLAB can't take control and deploy the code to it. So if you have like the Arduino IDE open at the same time, I would try closing that. The other thing I've seen is with non-officially branded Arduino boards, sometimes for most purposes, they are identical, but they have a couple small component differences. And I've had problems not just in MATLAB, with the Arduino IDE and other stuff where if I think it was like the serial controller or something was different. So there's a couple different things it could be. I would try, if you have the Arduino IDE, make sure you close that, make sure the COM port is set up right. You can ask on MATLAB Answers. There's also the tech support folks here at MathWorks who can help you with that.
And then so hopefully that was good advice for you, Shariar. But then you also asked about code generation functionality with the optimization toolbox. So I've sent some links over to our awesome video people, and they will pop them into the chat. But hopefully, there are a few functions in the optimization toolbox that generate code, so you can definitely take a look at it. There are some limitations on them because, again, the idea behind code generation is more towards either speeding up your code or getting it out of MATLAB into another environment, right? So sometimes the functions get a little complicated and they can't really generate code, but you also don't really need it because you're not taking it outside the MATLAB environment. So I have sent a link. They will pop into the chat, but you can take a look at you can take a look at all the optimization toolbox functions that our CodeGen supported. So hopefully that helps you.
Yeah. Okay. So I did have a bit of an issue there, and I'm actually going to have to reboot my Pi because if I go to my edge detection log, it's not able to open the I/O channel. So I've had this happen before. This is me trying to do things quickly instead of doing them the right way.
Hey,
all the time. But
live coding is fun, right? We have another question in the chat. It says, so Rohit Bhargava says he would like to know how MATLAB and Simulink interacts with TargetLink to generate production code.
Oh, TargetLink. TargetLink is not made by us. That's something that I think DSpace authors.
Yes, I believe so.
So I'm not super familiar with it, but it uses the same
the technology is the same.
The technology is the same.
Yeah.
When it's looking at MATLAB or Simulink to generate C code, it's using sort of the same pipeline. But it's got a bunch of customizations that they've written. So if you have questions about TargetLink, they're probably better directed at DSpace themselves, since they're the authors for TargetLink. But it's the actual process is the same. It's just how they choose to kind of go about doing the code gen, how they interpret it, and then how it gets deployed to different stuff. Yeah. So.
And just so you guys know, we've also got a note from our video team that says that they are actually awesome, and I agree. So, everyone, all right, you know what would make them really happy? If everyone that's on the stream right now goes and smash that bell button and subscribes to the MATLAB YouTube channel. Right on, guys.
You just wanted to say that.
I've been waiting. I've been waiting 40 minutes to say that.
All right, I rebooted the Pi. Because I was having a problem with this particular USB camera. I really just need to get a new one. But so now you can kind of see, if I maximize this, hopefully that'll get us going here. And we can take a look at edge detection. Again, same algorithm. I didn't actually make any changes, but now it's actually been code-gen, it's been turned into C code, and it's running directly on the Raspberry Pi. Yep. It's not actually interacting with MATLAB at all. Yep. Put my little guy in front of it. So
it's pretty cool.
Again, the edge detection example I'm using here, I'm not really doing anything useful with it, is the main thing, besides having a little bit of fun.
Yeah.
So that's sort of the MATLAB side of it. The next thing I've got is in Simulink. How are we doing on time? 11:43. Okay.
Yeah.
So let me just pop open this model. If you have seen our team, the student program team, has a training. The files are on the MathWorks GitHub page as well as on the File Exchange. It's the student competition CodeGen tutorial training.
Yes.
That one.
Our video team friends will drop a link in,
yes,
in the chat.
But that series of videos, it's sort of everything we've talked about now, but in more depth. It's kind of like a self-paced course, and it's got all of the files that you need to run it. And in that, in the version that you'll actually see like on the File Exchange, I've made a different branch here that I'm messing with. But on the File Exchange, the way that we do this is we're running some code on the Raspberry Pi that's trying to detect a little green ball that we're moving back and forth.
Right.
And then I've used all of my 6 years of mechanical engineering degree to securely fasten my webcam to a servo motor, which it's not going to go anywhere, but there may be structural tape involved. Normally what we would do is the camera would be hooked up to a Raspberry Pi, and we'd actually do the servo control on the Arduino. That's how we kind of do it in the video and how the files are set up. I just, to make this easier on us and not have a third board that we have to set up on live stream, I've moved all of it over to a single model that runs on the Pi. So let me go ahead and open that up. This will take a second because I haven't opened Simulink yet today. Let's see. I do see a question from the chat. Art Lenski asks, if my MATLAB script calls a MEX function and I generate C code, we'll be able to merge them properly into a compilable code. I don't know the answer to that. Do you?
I've never actually done something like that before.
I don't. So my gut instinct is, unless you are making another MEX function, I don't think so, because the MEX still requires MATLAB. It's
Right.
a MATLAB executable.
Right. Right.
So I don't think you can take that MEX function into pure C
Right.
without having the source file that generated the MEX.
That's actually a really good question. I don't think I've ever come across a use case like that. Because intuitively, I think that if I was doing something like that, I wouldn't MEX it. I just generate code from the MATLAB function itself.
Yeah.
But I could see a use case, like if someone's sharing a MEX file with you, right, when you don't have access to the code. That's a good question. We need to check on that. We can get back to you. Thank you for that.
Okay, so I know you've got your demo with the Jetson that I don't want to eat all our time here on it. But so what I've got now, this is the from the CodeGen tutorial training. I've sort of slapped together both of the models here, but I've got this Simulink model. If you haven't used Simulink before, go check out the live stream we did last week. We kind of did an intro to it leading up to this. But so this is going to be deployed onto my Pi, and what it's going to do is it's going to take the same video capture from my webcam. I've got this this vision algorithm that is detecting our region of interest. What it's looking for is a little green circle, and we're either going to use the green on my shirt or the head of my little model kit here, because I couldn't find our green ball. And then it takes that position and it figures out, okay, what angle do we want the servo to change to? And in the CodeGen tutorial, we would normally send that over serial. So we would connect a serial port, a USB port, between the Arduino and the Raspberry Pi. But in this case, I just wanted to keep it all in one place. So I have, I'm going to take that position where I think it is. I'm going to add a little ring to my image and throw it up on a display. And then the last thing I need to do is have this this servo write. So I had to massage this code a little bit because normally when we run this off the Arduino, we're actually using a different servo. It's a continuous servo.
Right.
This is just a standard servo, so it's got 180 degrees. And so what I've done is I've hooked it up to pin, if I open this. So I'm running this on a Pi 3 Model B, and I've opened up my pin map here to just take a look and make sure. And let me make sure that is, yes, okay. I had to move this, and I hopefully kept all the wires in place. But so I'm using GPIO 18 here. I've got it hooked up on a breadboard, so I can just send the commands out, as well as 5-volt power. Okay, so we are going to, let me double check. I might already have it compiled on here. I do actually. Let me just see if I run that, if it will go ahead and start up for me. Maybe not. Oops. Oh, that's just the messages about the DAC. Never mind. Okay. Well, let me go ahead. I'm gonna. I've already configured this model for code generation onto my Pi. So you can see I've got this this hardware tab, and that's where I've kind of told it, okay, I'm working on a Raspberry Pi. I can change hardware settings, or what I'm going to do is I'm going to run in monitor and tune. If you have been using Simulink a long time, I think the button used to be called external mode. But it's the same thing. What I want is I want to actually generate code, run it on the Pi, but I'm going to be streaming data back to my host computer, my laptop here. So this is going to CodeGen, it's going to build, it's going to transfer it onto the Raspberry Pi.
Let's wait and watch what happens. In the meantime, we have a question from Rupesh. Can code generation with the Arduino run in real time in case of image processing applications? Okay.
So If you're doing image processing, you probably don't want to work with an Arduino, in my experience, mainly because the Arduino is a bit more of a microcontroller, whereas like the Raspberry Pi I'm using is a single board computer. So it's got a graphics output. It's supposed to be doing that kind of stuff. There's a lot of discussion online about when Raspberry Pi is like the right choice and when Arduino is the right choice. And I just go look at those usually when I'm trying to decide. I don't know if you have a comment to make.
Well, I just think the way I've always thought about it is, if I'm doing anything image processing related, I'm usually picking a Raspberry Pi just because it's got more power, right?
Yeah.
But anything controls related, so like you want to control motors, you want to access sensor data, that's when I'm picking the Arduino. That being said, I'm not 100% sure if the Arduino is real time, like actual real time. I guess it's close enough, maybe.
Yeah.
So you to run something in like real time, you probably need something that's a little more powerful than that. But
for all intents and purposes, if the code runs on the Arduino, and your code's not like super complicated, you can treat it like it's real time.
Right.
But I'm sure we're opening ourselves up for a debate about how, what is real time, how fast is real time.
Right.
Yeah, I don't know that you'd really be able to do image processing on Arduino, not even in real time, just in general, because
unless you have one of those high-end Arduinos, but
oh yeah, well yeah, because there's
definitely not an Uno, that's for sure.
No.
Yeah.
So I have this running now.
There we go.
I finished code genning and it deployed, and you can see that my finagling to try and get these. Come on. I think I've got a sign flipped somewhere. But I'm controlling my servo. I'm trying to track.
Oh, there we go.
Uh,
I can see the dot on it.
Yeah, it's finding it. This is just my controller not being very good.
Yeah.
The actual vision algorithm's working fine.
Right.
And also using the wrong servo. But
there we go.
But I mean the goal here is honestly is that I was when I realized I had the wrong servo because I'm working in Simulink. We've got some of these blocks already put together for me. I was able to basically just flip over and say, all right, well, I'm not using a continuous servo, using a standard one. Let me write something really quick that I think is going to work. And I've got it code genned and running. It's not, running perfectly. And it's what it's doing right now is it's trying to find the green circle.
I think it's just finding my T-shirt.
I think it is.
All right, we have another question in the chat. I like this question. So Gideon says, I'm a novice in MATLAB. How do I become a champion? I don't know. Are we champion? No, we're just faking it, right? We just pretend. No. What I tell people when you want to try MATLAB, there are enough documentation examples for everything. So whatever fancies you, just go and open up a doc example. I mean, that's kind of what we did today, right? With the mech stuff. I don't think this is in the doc, but there's an example of this on GitHub. But yeah, just I mean, take it, try and break the code and fix it. I mean, that's as fun as that sounds. That's really how. Yeah. I mean, that's how I learn.
I think there's some resources that exist now that back in my day, 10 years ago or whatever, when I first installed MATLAB, that didn't exist back then.
Right.
And number one, MATLAB Online, which I know we haven't shown, but I think I showed it in the live stream last week. But the MATLAB on-ramp, the other on-ramps that are available on our website, and if there's a specific topic you're interested in, there's a lot of on-ramps for specific things like machine learning. I don't know if there's a computer vision one, but there's a Simulink on-ramp as well. Stateflow on-ramp. But there's also other courses that are that you can get access to, like MATLAB Fundamentals, which is much longer. I think it's like 16 hours. It's not that short, but
I think we can send a link to that in the chat. Let me look it up.
There's a lot of resources, not just like documentation, because documentation is good, but if you're really new, it's maybe you look at it and you're not really sure where to get started. But the self-paced training courses that we've got on there are a really good place to start. And I know there's also some folks at MathWorks have worked on some MOOCs, massive online open courses that use MATLAB and do some stuff. So those are also good things to check out. There's lots of kind of self-paced learning stuff, but there's also, like Connell said, there's tons of documentation on if there's a specific project or task that you want to try doing in MATLAB. There's probably an example that covers part of it, right? So
yeah. Another question. This application of tracking a green object, does your code detect which side? So that's how we set it up, right? Like, I don't know, maybe you can put up, there's a stateflow chart in there?
Yeah, so the real thing is that this is, it's a MATLAB function. It's finding the region of interest and outputting the X and Y. Like on the image, it's kind of figuring out what it's on.
Yeah, X and Y position.
And all this state flow chart is actually doing is it's got this MATLAB function to determine what angle we want to point the camera.
And then there's that set direction flow chart up there. So,
Yes,
what that's doing is we're saying, from 0 to 160, if it's from 0 to 160, it's on the left-hand side, and then so it'll turn to the left. And if it's 160 to I guess 320.
Yeah.
It's on the right-hand side. So it's setting that -1 or +1 direction. So yes, it is, but very crudely.
Yes, it's very. It just wants it to be. It's got a dead zone set up, so it is. If it's kind of near the center, it won't try to change the angle.
Yeah.
But if when you move it side to side, it just says, well, the green circle is moving to the left side of the image, so I want the servo to turn to the left some.
So this is Stateflow. I mean, Stateflow is a pretty cool. It's a pretty cool product. I really like Stateflow.
Yeah, I've done a lot of Stateflow. It's very useful for any sort of state machine, but also you can see that these are two different essentially flowcharts that you can combine in MATLAB, and you can see in this case we've got this function that instead of a flowchart or a state machine, it's also got like a MATLAB function it can call built into it. So,
all right, we're almost at the top of the hour, so maybe we don't have time to do the Jetson stuff because I'd rather take some questions from people in the chat.
Yeah, if there are. Do you have the Jetson running already?
I do have it running. If our guys can turn it on, I can show you what the model looks like and what it will look like once it's running on the Jetson. But no, I mean. One thing that we didn't have to talk about is the Simulink Student Challenge, right?
Oh, that's right.
Oh, there we go. We got the Jetson up and running. So
awesome.
Essentially, we've no. Yeah, I do funny things. Anyway, so what we have here is we took a Simulink model from my computer. We essentially built we built the Simulink model running ResNet. So ResNet is a very popular deep learning network. We deployed it to the Jetson, so it's running on the Jetson. And as you can see, those little tags on the left are telling you what it is, right? So
what it thinks
what it thinks it is, right? So let's try play around with a couple of things. Let's see what it thinks this is.
A modem, huh?
Thinks it's a modem or a hard disk, which is like I can see that. I mean, kind of.
Not quite focused.
Well, also not. Yeah, exactly.
You got your phone there?
I do have my phone here, so
let's see what it thinks that is.
So it definitely thinks that the Arduino is a hard disk, which is cool. Like it's kind of close. I can, computer. I do have my phone over here, so let's see what it thinks this is.
Oh, I saw iPod pop up, but
Polaroid
camera.
Oh, there we go. It's seeing the camera. Projector. Let me look at it this way.
I saw iPod again.
It's
iPod, iPhone,
Yeah, close enough. Well, hey, so we can pop in a link to that example as well on how to deploy the ResNet to any Jetson board really, whether it's it's a TX1, TX2, NVIDIA, the Jetson Nano, the Drive platform. There's a whole bunch of stuff. So. Unfortunately, we didn't have time to go through that but hopefully you can join us again and maybe we will.
Yeah. The one last thing I wanted to mention, I mentioned it at the end of the last live stream, was the Simulink Student Challenge is running. I think we'll have a link for that in the chat as well. I don't have the PowerPoint slide that I had last time up at the moment. But so if you've seen what we've done today, working with hardware, doing code gen, and it's really inspired you to try something out in Simulink. You can submit it's a short video about like what you did, what you're using Simulink for, and there's a prize available.
It is a cash prize, so
and you can see some of the cool stuff people have done in the past on the main page for the student challenge.
Yeah, we can pop in a link in the chat real quick, but yeah, I mean, sign up for it. It's a easy way to win some cash. I'm always looking for more cash to win.
I know the deadline for submission is in the second week of December. I think December 12th.
Yes.
But we should probably double check that
before
we sign off. Challenge details. December 12th.
Yeah, 1 p.m. Eastern. There we go.
So if you're interested, you just you got to submit submit by then, and the judging takes place later in December and January. So
yeah, and
but yeah, I think we're a little past 12 o'clock. So. I think that's about it, unless
unless you guys have any more questions, we can maybe hang around for a couple more minutes. But if we get a couple more questions, but if not, thank you so much for joining us. It's been a good time.
Yeah, 2 weeks
bump
in a row.
on that. Boom.
Well, cool. Thanks a lot for joining us.
Thanks, guys.